The reaction that we are about to discuss now is the conversion of an acid chloride into the corresponding amide. So let's draw the general scheme for that. This is an acid chloride. That's an acid chloride. Acid chlorides can be transformed into the corresponding amides of this general structure if the acid chloride is treated with an amine. So if we have NR2, then HNR2 as the amine. It's, of course, it is the nucleophile in this case. So that's the amine, that's the acid chloride. This is the amide that is desired. Now, we have mentioned before that two equivalents of the amine are required in this case, in this reaction of an acid chloride with the amine to form the corresponding amide. So two equivalents are actually required. Okay, let's now see why two. So one amine or if you like one mole equivalent of the amine does a nucleophilic acyl substitution reaction. Okay, so the amine attacks the acid chloride, nucleophilic addition step, followed by elimination of the leaving group. It's a nucleophilic acyl substitution. Overall, the intermediate that is formed is the following. This intermediate is formed. Now, what can come in at this stage is the chloride ion. It can actually come and take off that hydrogen. So the chloride ion, we can do that. That's possible. Chloride ion can come, take off this hydrogen, breaking that hydrogen nitrogen bond, releasing electrons to nitrogen. So what we get is actually the final amide product that appears in the scheme, plus HCl. So HCl is also formed. So far we have used 1 mole equivalent of the amine. The second mole equivalent is needed at this stage to react with HCl, the acid that is formed as a byproduct. So this byproduct acid reacts now with another mole equivalent of an amine. So the amine then comes in and it reacts with the acid byproduct to form an ammonium ion, as another product. So therefore, a second equivalent is needed, is required to react with the byproduct acid HCl. So overall, two equivalents of an amine is required. One equivalent does the nucleophilic acyl substitution reaction, and the second equivalent reacts with the byproduct acid that is formed in this reaction to form an ammonium ion. And of course, the advantage here is that ammonium ions, of course, are soluble in water. They can easily be separated in a workup step because they would be soluble in the aqueous phase, if you like, or the water layer. In general, and in summary, of course, this reaction is a very useful reaction because it allows transforming acid chlorides into amides by treating the acid chloride with two equivalents of an amine.